In the previous videos, we looked at how an isokinetic dynamometer works and how the device is adjusted for knee strength testing. Now we move to the actual measurement. This protocol is designed especially for monitoring athletes during ACL rehabilitation, but the same logic can also be applied to other rehabilitation situations. At the visit, the first mandatory step is to check the background information and screen for possible exclusion criteria. The tester asks about general health, medication, acute symptoms, current knee function, pain, and whether the person can understand and follow the instructions. After the screening, we move to the warm-up. The warm-up starts with 5 minutes of cycling at approximately 1.5 watts per kilogram of body mass. For example, if the person weighs 80 kilograms, the cycling power is roughly 120 watts. When cycling is not appropriate, for example after some hamstring procedures, the warm-up can also be done on a treadmill. The purpose is simple: increase temperature, improve readiness, and prepare the person for maximal efforts. After the aerobic warm-up, we continue with dynamic movements for the lower limbs and trunk. These may include lunges, single-leg deadlifts, and hops. Next, we assess reactive force production with drop jumps. Reactive force production is important in many sports because athletes often need to absorb force and produce force again very quickly. In this protocol, drop jumps are performed from a 30-centimeter box. First, the athlete performs 3 bilateral drop jumps. After that, 3 single-leg drop jumps starting with the dominant leg or the non-affected leg. And finally, 3 drop jumps with the non-dominant or affected leg. Between jumps, we allow about 20 seconds of rest so that each attempt can be performed with good quality. The drop jumps give information about contact time, flight time, jump height, and reactive strength index. As a measurement system, one can use an optical light bars, such as the one shown here. Other practical options include a force plate, a contact mat, or a validated video-based measurement application, such as MyJumpLab. These tests are useful because they show closed-chain performance, where the whole lower limb works together during a fast landing and takeoff task. This can reveal asymmetries that are not always visible in isolated strength testing. After the jump tests, we move to the Isokinetic dynamometer. After strapping the athlete into the chair, it is usually the perfect time to open the laptop and start running firmware updates. Or there is another option: do it before the athlete arrives. Here, the seat position, backrest, lever arm length, knee joint axis alignment, straps, range of motion, and safety limits have already been set. Now the person is familiarized with the movement using submaximal efforts. This is an important part of the protocol. The first repetitions on an isokinetic device often feel unusual. The person needs to learn how the lever arm moves, how the resistance feels, and how to produce maximal force through the selected range of motion. Familiarization improves reliability because the result is more likely to represent true performance rather than learning the task. We first test the dominant or non-involved leg. The isokinetic protocol includes 4 different strength qualities: maximum strength, speed strength, eccentric strength, and strength endurance. First, we test maximum strength. It is typically tested with concentric knee extension and flexion at 60 degrees per second, with 3 maximal repetitions. One repetition would be too few, because it may not reflect the best effort. A higher number would mostly add fatigue, without giving much more useful information about peak torque. Between tests, rest periods are used so the athlete can recover and produce reliable maximal efforts. The second test is speed strength. This test is also concentric, but the speed is higher, 240 degrees per second. Again, the athlete performs 3 maximal repetitions.
Koukista, ojenna, koukista, ojenna, koukista, ojenna, koukista, ojenna, koukista, ojenna.
At higher speeds, peak torque is usually lower, but the result tells us how well the athlete can produce force when time is limited. The third test is for eccentric strength. The angular velocity is slow, 30 degrees per second. Only 2 maximal repetitions are performed. During this test, the athlete resists the moving lever arm. Eccentric strength is important in tasks such as landing, decelerating, changing direction, and controlling the knee under high external loads. And finally, strength endurance. Here, the movement is concentric again. The speed is 180 degrees per second. The athlete performs 20 repetitions with full effort from start to finish. The tester also gives consistent verbal instructions, because encouragement, timing, and wording can affect the result.
Paina, paina.
Koukista, ojenna, koukista.
6 vielä.
Koukista.
Mennä loppuun asti.
Koukista, ojenna.
3 vielä.
Ojenna. Koukista.
Paina, paina.
Koukista, ojenna.
This test shows how force production decreases during a longer maximal effort. It also gives information about total work and fatigue in the quadriceps and hamstrings. The full protocol takes about 60 minutes, plus time for discussing the results. After the measurements, the data can be used to compare the injured and non-injured sides. The main focus is on peak torque. The peak torque values from the left and right sides can be used to calculate the limb symmetry index. Within the limb, the peak torques can also be used to calculate the hamstrings to quadriceps ratio. The test result is not just a collection of individual numbers, it is a comprehensive profile of lower limb strength and force-producing capacity. And that profile can be used to guide rehabilitation, support training decisions, and provide objective information for return to sport assessment. Thanks for watching.